Welcome to a trig substitution example with completing the square. So in this example, our job is to evaluate the indefinite integral, that is the integral of 1 over x squared minus 2x minus 3 dx. So we are going to start off with completing the square. So in that denominator, we have x squared minus 2x minus 3. And we are hoping to write this as an x squared minus 2x plus something. Then we have our minus 3 and we'll cancel out with a minus something. So to complete the square, we would take that negative 2, divide it by 2, and then square the results. So that winds up just being a 1. So we'll add on 1 to complete the square and subtract it back off to balance things back out. And we are looking at an x minus 1 in parentheses squared minus 4, otherwise known as x minus 1 in parentheses squared minus 2 squared. So our integral becomes, we have the integral of 1 over x squared minus 2x minus 3 dx is the same thing as the integral of 1 over x minus 1 squared minus 2 squared dx. We can do our right triangle trig using x minus 1, or we can perform u substitution. If we perform u substitution, we will go ahead and set u equal to x minus 1. And we have du is simply dx. And we have our integral is the integral of 1 over u squared minus 2 squared du. Setting up our right triangle trig, this u squared out front and then minus means that our hypotenuse is our u. So we are looking at a right triangle with a hypotenuse of u. We want our 2 to be the adjacent to theta, and then the opposite will be the square root of u squared minus 2 squared. Relationship involving u and 2 is that the secant of theta is equal to u over 2. So we have u is equal to 2 secant theta, and our du is 2 secant theta tangent theta d theta. And then the one involving the square root u squared minus 2 squared and 2 as tangent. So we have tangent of theta is equal to the square root of u squared minus 2 squared all over 2, which tells us that the square root of u squared minus 2 squared is equal to 2 times tangent of theta. So going back to our integral, we have the integral of 1 over x squared minus 2x minus 3 dx was equal to the integral of 1 over u squared minus 2 squared du. This is equal to the integral of 1 over the square root of u squared minus 2 squared, that whole thing squared du. So doing our substitution, this becomes the integral of 1 over 2 times tangent of theta, that entire 2 times tangent of theta squared. Then we are multiplying by du, and du was 2 times secant theta tan theta d theta. This becomes the integral of secant theta over 2 tangent theta. We can cancel out one of our 2's and our tangent theta, and then d theta. So we have a 1/2. I'm going to rewrite these in terms of sine and cosine and just see what we wind up with. So secant theta is 1 over cosine theta. Then we are dividing by tangent theta. So we are dividing by sine of theta over cosine theta d theta. So this becomes 1/2 the integral of 1 over cosine theta times cosine theta over sine theta d theta, otherwise known as 1/2 times the integral of 1 over sine theta d theta, better known as 1/2 times the integral of cosecant of theta d theta. Integral of cosecant, we know we are looking at 1/2 times negative, so negative 1/2 times the natural log of the absolute value of cosecant theta plus cotangent theta, and then plus c. At this point, we need to plug back in. So plugging back in, I'm going to just redraw the triangle. So if we redraw our triangle, for this triangle, we had a u on the hypotenuse, 2 as our adjacent, and then square root u squared minus 2 squared on the opposite. So cosecant of theta is hypotenuse over opposite. So that would be u over the square root of u squared minus 2 squared. In addition to that, we have cotangent of theta is adjacent over opposite. So that is 2 over the square root of u squared minus 2 squared. So we are looking at negative 1/2 times the natural log of the absolute value of u over the square root of u squared minus 2 squared plus 2 over the square root of u squared minus 2 squared and absolute value, and then plus c. We can rewrite this as a negative 1/2 times the natural log of the absolute value of u plus 2 over u squared minus 2 squared raised to the 1/2 for our denominator, then plus c. We can split this as a negative 1/2 times the natural log of the absolute value of u plus 2 minus a negative 1/2 times the natural log of the absolute value of u squared minus 2 squared raised to the 1/2 and absolute value plus c. This is a negative 1/2 times the natural log of the absolute value of u plus 2 plus 1/4, pulling out that exponent of 1/2, natural log of u plus 2, u minus 2, plus c. This becomes negative 1/2 times the natural log of the absolute value of u plus 2, plus 1/4 times the natural log of the absolute value of u plus 2. Again, splitting multiplication inside the logarithm becomes addition outside. So plus 1/4 times the natural log of the absolute value of u minus 2, and plus c. And this simplifies to 1/4 natural log of the absolute value of u minus 2 minus 1/4 times the natural log of the absolute value of u plus 2 plus c. Then we have our final substitution. We had set u equal to x minus 1. So plugging in u equals x minus 1, we are looking at 1/4 times the natural log of the absolute value of x minus 1 minus 2 minus 1/4 times the natural log of the absolute value of x minus 1 plus 2 plus c. And we wind up with 1/4 times the natural log of the absolute value of x minus 3 minus 1/4 times the natural log of the absolute value of x plus 1, then plus c. So there's some trig substitution involving u substitution as well after completing the square. We will go ahead and look at one more example that requires a few layers in the next video as well.